optimise it at a platform level. That's a great story, but actually the tagline at the bottom of the slide is the single most important thing on this slide, because of course it's not quite straightforward, reasonably straightforward to rapidly incubate technology. You can get an electrical motor, get it on a dyno, spin it and say, oh yeah, great, we've got a 300 kilowatt electric motor for an aerospace application. But to get to product, it must be fault tolerant, it must be fail safe. If it's driving a prop, it's probably a flight critical part of the system. So you have to be absolutely certain that the technology that you design will translate to a safe and certifiable product, particularly for an aerospace application. And not only that, even when you've crossed that threshold, whether it's 10 to the minus 6, 10 to the minus 9, once you've hit that aerospace standard, you still have to demonstrate that you can integrate it and optimize it at a system level, that it delivers meaningful power, and that you can also optimize it and deliver it at a platform level, that it makes economic sense. So when I think about sustainability, of course I think about sustainability through the prism of the environmental performance of what we're delivering. But the other meaning of the word sustainability is that it is enduring. And for a product to endure and deliver that environmental benefit, it has to make commercial sense. So you have to be able to get to scale, you have to be able to deliver volume, and you have to make sure you can operate it at a price point that a customer will pay for it, or an operator will acknowledge and embrace. All of that is a significant aerospace challenge, and it takes time. I would love to say that we'll have a product flying in a year's time, but some of this is just more hard engineering yards in some traditional aerospace challenges. You saw the megawatt machine that we were building up in Trondheim, and that's currently on test in Bristol, as Chris said. Last week we just delivered a megawatt of power. So that's a hybrid system. We have one of our AE 2100 gas turbines producing the power that then is running through that electrical machine and converting it and producing a megawatt of power. That has taken us 3 years, right? It is 3 years of learning to get to a point where we are generating a megawatt of meaningful electricity, right? And now we need to consider the steps from this point through certification and into a product. So again, when you're talking about delivering megawatts of power in an aerospace application, it is a really demanding challenge, and it's been a brilliant challenge that Rolls-Royce has been happy to sort of step up to and accept. And it gives us a huge amount of optimism about the future, because whether you believe you're delivering a megawatt scale EPU, that's perhaps an electric propulsion unit that's driven by a fuel cell, or whether you are embedding it in a gas turbine, there is still a long way to go to manage those thermal, those optimization challenges, the mechanical and structural challenges to turn it into a product. But those are our core skills in Rolls-Royce, that mechanical, structural, thermal challenges. We're used to optimizing that around a gas turbine. We're bringing the same skill set to look at how we deliver megawatt scale electrical applications. Oops, sorry. But it's not simply at megawatt scale. I talked about the advanced air mobility markets, and there are a couple of things we felt it was important to get moving on. Again, demonstrating technology. Now, when we think about technology, we have a real preference. If we're going to demonstrate it, we want to see that it has a route through certification. These were just some early programs that allow us to get moving. So Accel, this is the spirit of innovation, an aircraft that is currently flying and just building up to some world record attempts for the electric airspeed record. This is the City Airbus eVTOL. This is one of the largest eVTOL aircraft that have flown, powered by Rolls-Royce machines. So we successfully supported Airbus's flight test program last year. Absolutely thrilled to see the performance of that platform and the learning that we got from the machines that we had on that platform, which inform the iteration of our offering into urban air mobility. And on the right, H3PS, a program that we're just running with Tecnam, where we will deliver a parallel hybrid electric propulsion system just into a flight test program. The important point here was, again, to the point that Chris made, you can incubate and develop technology, but it makes sense of it. You can only make sense of it at a platform level. So having really strong platform partners helps you make sure you've got a route from technology through certification and into scale production. So of course, more recently we've been visible in the market announcing some of those longer term partnerships. particularly proud to talk about our relationship with Vertical Aerospace and their platform, the VX4, where we will be providing the electric propulsion unit, so the motor and the power electronics and the power distribution system, and also with Tecnam on the P-Volt, where we will deliver a full battery electric system. So that is the battery, the energy storage system, the power distribution system, and the motors which will drive the props. And again, we wanted to be really, really focused on aligning ourselves with world-class partners who had a focus on getting to a certified product. Because obviously that is our challenge to commercialise the technology and drive that meaningful step change in the environmental performance of some of the markets in our industry. And of course, some of that requires some heavy-duty investment and focus. So we're very clear in our thesis that we're going to be developing our own energy storage systems. I think we're on our 7th generation battery design at the moment, and now focusing on the batteries that will take us through into certified products, whether it's in urban air mobility, that commuter market that I showed you with P-Volt, the fixed wing aircraft, or a booster battery that would sit in a hybrid electric system and just give a bit of boost and lift, change the way you operate your GT. And here also is a turbo generator. It's a small gas turbine, and we will embed a generator in that GT. So that will be, the hundreds of kilowatts. It will not be at a megawatt scale, but we have been busy practicing how you embed electrical machines in gas turbines so that you can deliver more platform power if you need it from a GT, or you can change the operating cycle of the gas turbine so you're not stressing it as much because you get a bit of electrical power offtake. You can use a battery instead of the GT, say in lift, so that you can run it at a more simple cycle and not put the GT under as much pressure as you might otherwise do. So you get an operating cost benefit and you get an environmental performance benefit from it. So you hear a lot more from us talking about turbo generators in the months to come, and we're developing our capability at our site in Darlowitz with a really strong focus on hybrid electric flight. Of course, talked a lot about technology and power and propulsion systems. When we talk about particularly the advanced air mobility markets, whether that's urban air mobility or regional air mobility, that's a very different operating model to our core businesses today. And you see a proliferation of airports that could be enabled by this different operating profile of an aircraft with an electric system. The benefit for Rolls-Royce is that we're able to leverage the fantastic heritage and track record we have in data management, fleet optimization, everything that you need to understand how you optimize your platform, how you optimize the system to deliver an economic benefit for your customer, sustain time on wing, keep the aircraft in the air for as many hours as possible. We're not starting from a clean sheet. We have all this capability in Rolls-Royce today that we're able to leverage. And the same is true from a service perspective. Okay, if you have a proliferation, if you have thousands of these different types of aircraft connecting towns and cities, you have to think about how you're going to sustainably service that model and support that infrastructure. And the benefit of being in a group like Rolls-Royce, of course, is that we have both that know-how and that infrastructure today. Whether it's at large scale with our civil aerospace business, or it's our helicopter engine service model that we have, or even leveraging some of the capability that we have in power systems and their generation capability around the world. And I think that's where I wanted to finish, was a final comment around the power that matters. So in Rolls-Royce we talk about pioneering the power that matters, alongside talking about the power and propulsion system. With a very strong aerospace focus, in our group we have a world-class industrial power business, Rolls-Royce Power Systems, and the power systems teams already have microgrids. They're introducing a fuel cell into their microgrid solution, so we have clean power that we can offer to airports and at the critical points of infrastructure. If it's a vertiport in urban air mobility, if you're operating a regional airfield and you want to have an electric aircraft operating on that airfield, at Rolls-Royce we already have containerised batteries that we can drop in and provide a charging solution, and we can scale that through our microgrids. We can scale it all the way through to a small modular reactor, depending on the power requirement that enables this mode of transport. So we're not simply thinking about how you deliver the power and propulsion solution, we're thinking about the full ecosystem and how we leverage our world-class technology and our engineering capability to deliver a sustainable ecosystem for the market. I'll pause there. Thank you very much.